Good morning, everyone, and welcome to Lockdown Webinar number 6. My name is Keira Proctor, and I'm the Managing Director of the A. Proctor Group Limited. And today, we're going to look at high-rise and modular construction and how membranes can be used in facade and roofing application on these kinds of projects. As usual, we'll follow up with a Q&A session, so any questions you have for our team, you can type them into the chat box here, DM us on Twitter @Proctor Group, or email webinar@proctorgroup.com. We're going to start off today by looking at some of the key principles of design for manufacturing and assembly. We'll then consider the ways in which we can use a variety of construction membranes to both align with these principles and comply with the building regulations. Following on from this, we'll consider how these strategies and materials can be applied to facade systems, both low and high-rise, and how they can be incorporated in upgrade works. Finally, we'll take a look at some projects where the principles have been put into effect on sites. Design for manufacture and assembly, or DFMA, is an approach traditionally used by other industries, such as manufacturing consumer products. This focused on the role of the designer in increasing both efficiency and quality of the manufacturing process. The basic principles are based on recommendations going back to the Egan report, Rethinking Construction, in the late 1990s, which focused on more tightly integrating project processes, adopting techniques and strategies from higher volume industries like automotive, to, in Egan's words, do it entirely differently. How feasible the entirety of the Egan report was, or remains, is something we could discuss for several lockdowns and still not resolve. But the spirit of the report can be clearly identified in the off-site sector, where factory-based manufacturing simplifies the adoption of this approach. The key principles can be identified as: minimise components, thereby simplifying supply chains and assembly processes both on and off-site. Ease of fabrication, focusing on using adhesive bonding rather than mechanical fixings where appropriate, and ensure the design facilitates the ease of both off-site manufacture and on-site assembly. Tolerance and clarity of parts, ensuring the design performance criteria are within the capabilities of the manufacturing and assembly processes, and minimise the scope for unclear processes to produce substandard results. Minimise the on-site use of flexible components such as gaskets and rubber seals, which can be more difficult to handle and correctly assemble, particularly under adverse conditions. Finally, reducing adjustments. By reducing or eliminating the requirements to make intentional fine adjustments, the necessity of unintentional adjustments can also be minimised. Taken together, these principles aim to ensure that the design performance of the building envelope matches what is built, not simply by demanding strict adherence to design specifications, but by writing those specs to ensure adherence is the simplest and therefore most likely outcome. The various approaches to construction derived from these principles are typically referred to as modern methods of construction, a broad term encompassing everything from timber frame housing to 3D printed concrete elements or cross-laminated timber structures. The common thread of all these types of building is, however, reducing the scope for variations in design performance, arising from the construction process itself by shifting processes off-site into a more controlled environment. In this context, construction membranes have several important roles to play in ensuring these objectives can be met. But in order to maximise their effectiveness, there is a need to properly understand the range of design considerations applicable. Anyone who's been following our series of webinars recently will hopefully be pretty familiar with this diagram now, as understanding and controlling the heat, air and moisture movement within structures is the core principle of what we do here at the Proctor Group. In the context of our discussions today, we have a broad range of factors influencing this, as these methods of constructions can be and are applied to every type of structure. Timber frame has long been used in domestic housing, particularly up here in Scotland, but it's becoming increasingly common in other sectors and geographical areas. Likewise, volumetric building is increasing and expanding, and systems historically more typical of high-rise are finding use on low-rise projects. So, it's becoming more likely than ever that specifiers will have to learn to work with a huge variety of different detailing techniques and materials. Whatever the situation, the first thing we need to consider is the type of building fabric we are dealing with. Concrete, steel, and timber-based buildings all respond differently to moisture and contain different amounts of construction moisture which must be allowed to dry out. For example, buildings with a lot of in-situ concrete can take several years to fully dry out. This excess moisture load must be accounted for at the design stage. Construction moisture can also come from the weather, and this must also be taken into account along with the weather conditions the building will be subjected to once completed. Being weathertight earlier in the construction process and generally being composed of drier materials, off-site construction has an important advantage hygrothermally. By reducing the initial moisture loading on the building fabric, the design can be more precisely tailored to manage moisture associated with the occupants of the building and the uses the building will be put to, leading in turn to a more efficient fabric envelope and building system. The influences of these three aspects can then be assessed in terms of the heat, air, and moisture movement within the building. This takes into account the heating of the building as well as the air leakage effects and response of the building fabric to the absorption and desorption of moisture. Factors such as the position and performance of the fabric insulation can also be considered. Building regulations. As with any type of construction, the basis of good design in modular construction comes from a good understanding of the building regulations themselves. Today, we'll be focusing mainly on the documents relating to energy performance and condensation control. So that would be Approved Documents L and F in England and Wales, Technical Standards 3 and 6 in Scotland, Technical Booklets K and F in Northern Ireland, and Guidance Documents L and F in the Republic of Ireland. We'll also consider the implications of these systems on fire performance, which is covered in Part B for England and Wales, Section 2 in Scotland, Part E in Northern Ireland, and Technical Guidance Document B in the Republic of Ireland. While the specific details in these documents may vary a little, the principles behind the guidance and the recommended approaches are broadly similar. So, while we try and keep things as broadly applicable as possible, we'll flag up any significant differences where they arise. The primary design consideration we're looking at here is limiting unplanned air movement throughout the building fabric, whilst reducing the risks associated with condensation and excess moisture. The most important of these considerations is where in the building element we place both our vapour control layer and our air barrier layer. Traditionally, these two functions would be performed by the same membrane, as most vapour control layers will also perform the function of an air barrier. It's by no means a given that this method is suitable for all projects, however, and this is particularly true of facade systems. For some facade build-ups, the vapour control function may not even be necessary, and the inclusion of the vapour control layer simply adds an additional process and more complexity for no benefit, just one more thing to go wrong. Which leads to a third consideration. Is using a vapour barrier to control air leakage in fact a liability? While this certainly isn't the case on every project, if our overall design strategy is to simplify and reduce potential points of failure in the design, it's something worth bearing in mind. If we're proposing removing the vapour control layer, we need to be sure that the element is capable of controlling any risk of condensation. As regular viewers of our webinar, you will know by now there are a couple of different ways we can look at assessing these risks. Historically, a process known as the Glaser method was used to assess this. However, this method makes a few assumptions that limit its accuracy. In contrast, the newer Woofy method allows us to account for the variable external influence of weather conditions, along with the effects of the fabric's capacity to store and release moisture. We can also look at how these factors interact over longer time periods. The steady-state analysis used in the Glaser method, while useful for quick and simple checks, does not always provide a sufficiently detailed picture of the long-term performance of the structure. This more detailed analysis can allow us to consider solutions that may not appear acceptable when assessed under the Glaser method. In our example construction here, the internal vapour control layer can be removed altogether without creating a condensation risk. If we remove the vapour control layer, we still need to manage our air leakage, and this can be done simply and effectively using an external air barrier membrane, like our Airtight. This simplified and more effective process allows designers to target more ambitious air leakage rates at the design stage, taking advantage of the improvements in energy performance this brings. Reducing the air leakage from 3 meters cubed per square meter per hour down to 1 can have significant positive impact on the energy performance of the building, meaning we can reduce the insulation thickness required or the specification of the insulation boards themselves. This can offer designers more flexibility in insulation types used, for example as regards fire performance or increasing internal space available to occupants. If implemented in the design at an early stage, this enhanced airtightness does not lead to the building requiring complex mechanical ventilation systems, as other options such as passive ventilation strategies can be implemented. We can, however, only take full advantage of this flexibility if we can depend on achieving the air leakage targets that we use in the design process. As we can see here, if we keep the air barrier internal, that means a lot of tape and mastic required to seal all the switches, sockets, pipework and other services that modern buildings require. A lot of the sealing can be done off-site, but it still takes a lot of time to do correctly and further care is required to ensure the seals are not broken or damaged during transportation and assembly. Even small punctures, broken or misaligned seals or loose tape can significantly increase the air leakage rate when tested, leading to expensive and difficult remediation measures to meet regulation requirements. This process can be speeded up somewhat by using proprietary seals and components, but this can increase costs and complicate supply chains. Using a fully adhered external air barrier removes this problem completely, ensuring that the panels arrive in position perfectly sealed and the performance and practice match the design criteria without requiring any unusual measures or specialist products during the construction process. In volumetric systems, incorporating an external air barrier is straightforward and brings several benefits over traditional mechanically fixed membranes. The membrane can be applied to the new panels in any orientation, and being self-adhered requires no mechanical fixings. This adhesion reduces the potential for membrane damage, both during the module assembly process and whilst in transit to site. The panels are then assembled and the joints taped using the same material in tape form, ensuring no adhesion issues or tape compatibility problems. Once the joints are taped, the panel assembly is resistant to air leakage, and any service installations such as wiring or pipework can be undertaken independently without risking damage to the airtight layer. These wall, roof and floor panels can then be assembled into modules, and the wrap-tight split liner tape used to complete the airtight seal between adjacent assemblies. This tape simplifies making such joints by splitting the release liner in half, allowing the two surfaces to be stuck independently, making the joint faster and more accurate. These completed modules can then be transported to site. During transportation, the self-adhered membrane ensures watertightness, protecting internal components and minimising on-site remediation work. The building can then be assembled on site and completed as normal. Many systems are accredited within BOPAS, Building Property Assurance Scheme, which offers assurance of structural integrity for modern methods of construction. To date, wrap-tight is currently included within 2 systems. The airtightness advantages of wrap-tight can also be realised in warm roof applications, such as we can see here on this local authority children's home in Hampshire. In this case, the wrap-tight membrane is used on both the timber frame walls and roof, allowing the airtight layer to remain fully continuous around the entire structure. The wrap-tight membrane is fully BBA certified for warm roof applications, making this type of construction a simple and effective route to good air barrier detailing on site, as the membrane on off-site panels can be jointed simply with wrap-tight tape. Alternatively, if the roof membrane is installed on site, it can be simply wrapped around the eaves and lapped onto the wall panels without leaving any gaps for air leakage or water ingress during construction. As well as ensuring the integrity of the air barrier is maintained, the self-adhered wrap-tight membrane brings important benefits in terms of fire resistance. Since December 2018, membranes used in external walls over 18 metres in height have required a minimum fire rating of B-S3D0. In Scotland, this is reduced to 11 metres in height. While there are some materials with A1 or A2 ratings that can be used to provide weather protection, they typically don't offer sufficient vapour permeability to ensure a healthy building envelope is maintained, by allowing construction moisture in particular to dry out. Class B membranes are far better in permeability terms, and don't usually contribute enough calorific value to have a significant effect on the development of a fire. The BR135 guidance document uses the following model to illustrate the development of a fire. A rapid fire spread occurs when initial fire develops and flashes over, and is then spread to all areas simultaneously by the outer cladding layers. This then starts fires across all the areas of the building. In cases of restricted fire spread, the initial fire develops and flashes over, but it is then either contained or will ignite a single secondary fire directly adjacent. The fire will only develop further if this secondary fire also develops. This is a much slower process. Let us consider solely how the membrane in facade construction reacts to fire. If the membrane is mechanically fixed and taped, there is a potential for fire to spread on both surfaces of the material, as oxygen can feed into the fire on either side. This additional oxygen supply can also allow the fire to develop more rapidly. With a fully adhered membrane like Raptite, only the outer surface can contribute to the development of the fire, as there are no gaps between the membrane and the substrate. This inhibits the supply of oxygen to the fire and slows down the spread of fire across the membrane. So, we've looked at how the Raptite membrane reacts to fire and how it complies with the relevant technical standards. But if we want to go beyond fire resistance and introduce a degree of fire protection, then another option is to use the Fire Shield membrane. Fire Shield is a vapor-permeable membrane with a unique surface composition which actively reacts to prevent fire taking hold. Fire Shield can be used over insulation boards to provide an additional layer of fire protection to the internal structure of the building, or can be used directly onto the sheathing boards of a timber frame structure. In this comparative test conducted by the University of Edinburgh, based on the EN 13823 single burning item test, the Fire Shield on the left reacts substantially less than the other Class B fire-resisting membrane on the right. The surface of the Fire Shield acts similarly to an intumescent coating, frothing up to protect the insulation boards and structure. In this test, the unique coating protects the sheathing long enough for the external fuel source to be exhausted and for the fire to self-extinguish. The standard Class B membrane, although it shrinks away and does not contribute to the development of the fire, does nothing to protect the structure or delay the progression of the fire. Used in this way, Fire Shield can help prevent fire from outside the building, causing damage both during construction and in service. During the construction process, Fire Shield can also be used on the external cavity face to improve fire robustness of closed panel assemblies when installed over external sheathing alongside suitable non-combustible internal linings. Fire Shield is the first fire-resistant vapor-permeable membrane approved for inclusion in the Structural Timber Association tested product listing for fire robustness during construction. As part of an appropriately tested construction, Fire Shield can be used as part of a system to limit the spread of fire, which can allow for reduced spacing to adjacent properties. This must, however, be done in accordance with the Structural Timber Association's procedures and test methods. The first of our example projects is a new build apartment development where the original design called for an air leakage rate of 5 and used rigid PIR foam insulation over a concrete frame. After the tragic events of Grenfell in 2017, a priority for this project was to replace the originally specified PIR foam insulation board with the incombustible mineral fibre. This introduced a substantial shortfall in thermal performance, which the designers were not keen to offset via increased thickness. Specifying Raptite as their air barrier membrane allowed the designed air leakage to be reduced from 5 to 3, going some way to offsetting this increase in thickness. As well as the obvious reduction in building footprint from the reduced insulation thickness, there were several additional benefits. A detailed WUFI condensation risk analysis on the use of Raptite allowed the removal of the internal vapour control layer and its associated installation costs. The use of Raptite also allowed a reduction in the specification of the sheathing boards, owing to the weather tightness of the membrane externally, and reduced the requirement for EPDM membrane over the structural frame, infills and at flashings around windows. Taken together, the cost savings from these changes more than offset the increase in membrane costs from the use of Raptite, allowing the specific project goals of improved fire performance to be delivered alongside a cost saving. Our second example is a recladding project, where an existing residential high-rise with a facade of ACM panels was being refurbished and upgraded to incorporate a material with enhanced reaction to fire performance. In this project, the existing ACM panels and rigid foam insulation boards were completely removed from the facades and replaced with mineral fibre insulation and incombustible cladding panels. As part of these works, the vapor-permeable fire shield membrane was specified to provide additional protection not only from weather but also from fire spread within the cladding system. As part of a project specifically focused on reducing the combustibility of the entire facade construction, the intumescent surface of the fire shield membrane made it the obvious choice of membrane to provide temporary weather protection without compromising the overall project objectives. So whether the primary aspects of a project are airtightness, weather tightness, or fire performance, construction membranes have an important role to play in facade systems and off-site construction for both new build and refurbishment projects. Now we'll move on to the Q&A session. Good morning, everyone. Thank you very much for joining our 6th lockdown webinar. Like everyone, I'm sure you're looking forward not to having to use the word lockdown. But as I've said in previous webinars, we are committed to doing one every Friday during lockdown and perhaps beyond. So we will see how it goes. I hope you're all having a nice Friday. And looking forward to the weekend, of course. As you're aware, if you have joined the webinar before, we stay on it and we answer all your questions. We will not be offended if you have to leave early and have somewhere to be, but we will stay on and answer anything that comes through on the YouTube chat or via the email or however the questions may be coming through. So please feel free to post them in the YouTube chat. Our next webinar is now live. So you can actually go onto the webinar page on the Proctor Group's website. So www.proctorgroup.com/webinar and register for next week. Now, next week's webinar is quite specific. It's regarding protection of brownfield sites, protection of buildings on brownfield sites. And afterwards, we will be having a live Q&A as always. You can get a personalised CPD certification for today's webinar, so please follow the link in the description below. We do love getting your feedback. I personally read all of it. We had some great feedback last week. My personal favourite just said flawless, which I'm not sure is quite true, but thank you very much if you sent that through. So please send it through. You will receive an email after this if you've registered, which will have all the links I've described above, including the ability to circulate this webinar replay. So please send it to colleagues, fill out the survey, register for next week's, and give us any feedback that you may have. So if you've attended our webinars before, you will have seen some of these faces or a couple of others who haven't been chosen for asked to attend today's webinar for various reasons, if they're too busy or they're working on other things. So we've got a great team here today again. So Sue, Mark, Callum and James. So I'll introduce them quickly for others that haven't met them. Sue is in our technical team, has been for 27 years, so very knowledgeable, all things Proctor and all things technical. She's based in Blairgowrie, just near our offices, which of course are now shut at the moment. Callum Anderson is based in Crieff, which is a gorgeous area of Scotland, in Perthshire in Scotland, and he is, I think it's fair to say, you're kind of our woofy specialist, hygrothermal specialist, along with a great knowledge in all things technical as well. Mark has had 34 years in the construction industry, has been with Proctor before, has rejoined us, which is fantastic. He is the business development manager for High Rise, Facade and Modular. So we didn't change his job title just for this webinar. That's been his job title for a while. So great asset to the team. And James is based in Eastbourne, and James is our specification manager covering the London area, well, covering a lot of areas at the moment actually, and while we have less staff working. And again, a lot of excellent experience in the construction sector, background with a lot of different companies and a lot of links into specification. So I'm very hopeful that we can answer all your questions, so please keep them coming in. So I will just start away. We tend to get most through DM on Twitter or on email, so please bear with me if I'm kind of looking and asking at the same time. I'll try my best to multitask. So we have one in on the Twitter DM feed from Paul. So Sue, if I can just start with you, please. Okay, so is it really practical to install an air barrier externally? Won't this cause condensation issues?
Okay, so yes, it's actually very practical to install the air barrier on the outside. Obviously, wrap tight is vapor permeable as well as being airtight as well. And as we saw in the presentation there, installing it externally means that you don't have the issues of trying to get around all the penetrations and the junctions that you would have if you were installing it internally. Whether or not you need a separate vapour control layer will depend on the rest of the actual construction, but that is something that we can obviously have a look at, and we can run the condensation risk analysis or roofing calculations to determine whether that is actually even needed.
Okay, so that's something that we would do in-house if we had specific project details or the build-up of the wall, yeah?
Absolutely.
Okay, great. One on the YouTube, not speaking very well today, on the YouTube feed, Mark, I think I'll come to you first on the YouTube one, if that's all right. James has asked, can Raptite accommodate lightweight metal roof tile or standing seam roof finishes?
Right, yeah. Morning, everyone. If we think back to last week's webinar, we were dealing with vapor permeable roofing underlays, and we talked about the PII research. And what that did, it was independent research that was looking at all types of primary roof coverings. And what it identified was that the bulk of the primary roof coverings on the market are all sufficiently air and vapor open. So when the water vapor passes through the membrane, it can freely escape through to outside atmosphere. With the use of lightweight metal roof tile systems and standing seam, these are very close fitting and very uniform tile systems. So what effectively happens is when the water vapor is passing through the construction through the membrane, it's then trapped and can't escape through to outside atmosphere. So what you need to consider really is the use of ventilation. And you should install ventilation at low and at high level, and that would create sort of a stack effect that will draw that moisture then out through the roof space and prevent any interstitial condensation from forming. So it's important to ventilate. In order to do that, with the metal roof tile systems, you'll need to use a counter batten. So I guess minimum 12 millimeters thick. And by having a counter batten, it allows any moisture that would form within that cavity, as it were, beneath that sealed roof system to run straight down to the gutter. In terms of the standing seam, those systems are generally installed using a clip system, and there's a ventilation mat that is available on the market, which is there for drainage and for ventilation, a polypropylene type matting, commonly known as the hairy chestwig. So that's what you need to install over the top of that tie to ensure that there's free ventilation and any interstitial condensation can go down to the gutter.
Okay, that's great. Thanks, Mark. Callum, Jolene has asked, how would concrete frames, e.g. slabs and columns, be detailed across?
So usually with a mechanically fixed membrane, you would need to use a EPDM in these locations. But with Raptite, you can adhere directly from the sheathing board on the SFS directly across the concrete, so it would stick to both. So this really simplifies that detail.
Okay, good. And another one, can it improve the U value of a construction?
No, it can't. The thermal resistance of Raptite would be almost completely completely negligible. In our U value calculations, we would class it as having zero thermal properties at all. Okay. It can actually make the U value worse. If you're taking a SAP calculation or SBEM calculation, you would have a dwelling emissions rate, and if you maintain the same dwelling emissions rate but increase the airtightness, you can actually use a worse U value to offset it. So in that way, we explained in the webinar earlier that we managed to reduce the thickness of a bit of insulation on our construction so that it would meet the same performance.
Okay, that's good. Thank you very much, Callum. James, you thought you were getting away scot-free there. I'll come to you with a couple if that's okay. So the first one from Will, how does Raptite work at junctions with fire barriers within a cavity?
Okay, great question, Will, thank you. In regards to the Raptite, because of the nature of the product, in regards to the self-adhesive nature of the product, it will quite easily bond back to the substrate, obviously from the sheathing board to the concrete slab where your fire barrier will be positioned in regards to a facade system. In regards to the fixing details, there's a multitude of different fixings out there, obviously. But obviously from our design point of view, if you can provide those details of the fire barrier, of the fixings that are required, what we can do is assist in the design process to make sure that one, obviously you maintain the air tightness and you can keep the continuity of the membrane over that facade system. Again, there's many different types of barriers out there, so please let us know which one's being utilised, and we can assist as much as we can be, which obviously makes sure that we're not putting the envelope at risk, or indeed the performance of the building, which potentially, obviously, if you're jeopardising the air tightness of the product, then you may fail in your air pressure testing once the building's complete. But obviously, as per usual, much detail in regards to the products being required, we will need in order to make sure that we can give the correct advice in regards to installation as well.
Okay, good. Just seeing as that was a question on fire barriers, and there's a couple more coming through in relation to fire, I just wanted to mention, I know I explained that next week's webinar is protecting buildings on sites with contaminated land. The week after, we're working to put together, we will have by a week on Friday, fire performance and construction membranes within fire performance and how they perform. So I don't think we've actually given a title for the webinar yet, but it will be fire related and will be really educational in terms of fire regulations, fire performance, and how that all comes together. So that will be the 29th of May at 10 a.m. If people want to make a note, it'll be a really interesting one. James, so another question from Will as well, that the same chap has asked, do you need thermal brakes on the back of the hanging brackets?
From a Proctor Group, from belt and braces philosophy, then yes, we'd always stipulate that you put a thermal brake on the back of the product. As Callum alluded to earlier, or Sue, I can't remember who it was, in regards to the thermal performance of the product, we're not really in regards to that thermal performance, so enabling where you've got the penetration obviously through the system, having that thermal brake behind there is the best route forward. From Callum's point of view, from Sue's point of view, from a specification point of view, we'll always put a thermal brake on the back of those brackets. Whether they're chosen to be utilised or not is down to the contractor at the end of the day.
Okay, great. Mark, if I can come back to you, there's a couple on YouTube here. If I can just ask you one from Declan, please. I'm not sure if you're seeing these at the same time, but can Raptite overlap an existing EPDM that is in place around the windows of a high-rise building?
Yes, it can. There's two ways of detailing the Raptite. One is to install the Raptite first and dress that into the windows and then apply the EPDM. The other approach is actually to where the EPDM is already in position. So you can bring the Raptite down and dress it around and onto the EPDM, and we can offer advice on how to detail that. So we have a liquid flashing that can protect the leading edge of the membrane and that type of thing if we can't get this sort of effect where we want the water to drain clearly off the membrane. But yeah, it's simple to detail. There's two approaches, and both have been successfully employed on sites.
Okay, great. Thanks, Mark. And Mark, if I can ask you one invite by email now, please, and while I've got you there. Sam has asked, in remediation works of high-rise residential buildings where the windows are already installed, is it possible to incorporate your self-adhesive membrane? Yeah,
I guess this question fits in with the one we just sort of responded to, really, is the fact that where we've got existing windows in place with the EPDM or waterproofing around those windows, it can be very difficult to install the standard Raptite membrane at 1.5 metres wide if you're constantly trying to cut it around all these different sort of penetrations and things. So what we can do, and what we have successfully done, is we can pre-cut the Raptite to suit those window openings. So those are going to be uniform, both horizontally and vertically. So we can pre-cut the membrane down from 1.5 to say to 400 mil wide bands, as it were. And then those can progress simply down between all the window openings, lapping onto the EPDM. So I guess, first of all, to create that effect where we're going to have moisture running clearly down off the membrane, the shingle effect, as it were, you'd probably put the horizontals on first and then bring down vertically the membrane between the windows. And as I said earlier, we can detail them with Raptite liquid flashing. So it's quite an easy way to do it. Takes a little bit more time. Obviously, it's non-standard. Every project's different. So just pick the phone up and talk to us, and let's have a look at the drawings, and let's see what dimensions we need to pre-cut the wrap-tight membrane to.
Okay, great. Sue Bodwox has asked, when using Fire Shield, does it also provide the wrap-tight properties in conjunction with its intumescent value? So it's from Roderick, sorry, that must be his handle.
Okay. Both membranes are vapor permeable, and they're also airtight as well. There are different advantages, different properties between the two. With the Fire Shield, in order to get the airtightness, you will obviously have to tape the joints, whereas the wrap-tight, as we know, is self-adhesive, so it's it gets fairly easy to install without additional accessories. The Fire Shield obviously performs slightly different in terms of fire because of the intumescent nature, but that means it must be placed adjacent to the cavity of the facade, whereas wrap-tight can be installed against the sheathing earlier on in the construction. So there's advantages of both, and it would really depend on the requirements that you're actually looking for your project.
Okay, perfect. And one from Joel. Sue, can you just explain what is the advantage of using wrap-tight in modular build?
Okay, well, as well as the technical properties of wrap-tight, so the airtightness, the vapor permeability, the ease of installation, etc. One of the main advantages is because of its self-adhesive nature, during the actual construction and assembly, along with like transit onto site and builds there's less likelihood of damage because the membrane is not loose, it's fully adhered.
Okay, so none of the flapping in the wind. Okay.
Absolutely.
And again, more assured performance of the actual building envelope as designed, I guess.
Exactly.
Good, okay. Let me have a look here. So Michael has asked, and again, Mark, perhaps would be a good one for you to answer. How does the wrap-tight work when you're puncturing it with the likes of brick wall ties and which need to be nailed to a timber panel?
We probably need to look at things in each case. I mean, if we look at high-rise projects, for example, they're typically installed using an Ancon wall system. So fixing goes through the membrane, and then there's a rail fixed on the front, and then the wall ties are clipped into that. There is a degree of sealing, certainly in terms of an airtightness point of view. So it's not really an issue. If there is any sort of damage to the membrane as you're puncturing it through, again, you could use the wrap-tight liquid flashing just to seal around there. So if there's any rips, tears, or anything like that, but it's not proven to be a problem at all on projects to date. So again, please pick the phone up, actually get us on site if necessary, and we can talk you through the how to do things properly.
Well, not at the moment. We can do it remotely, of course, as we're doing
with my phones. So.
Yeah, that's it. FaceTime,
yeah.
FaceTime site visits. Okay, James, I have a question for Mark, obviously not our Mark. Yeah. How does the wrap-tight bridge the expansion joints within the facade?
Okay, yeah. So from a high-rise perspective, obviously you've got the sheathing board. What you'll have is the structural engineer will put together where the expansion joints need to be within that sheathing board layer. With the wrap-tight product, it's got a 10 to 15 mil deflection that's possible to bridge with the product. So therefore, there is no issue in regards to having the product running up over that expansion joint. It will literally sit proud of where the expansion joint is. Obviously, you'll have your filler rod within that expansion joint to allow that to move. But the product will obviously move with the settlement of the building and the movement of the building at the same time. But again, supply us with the details if we need to work with the structural engineer to provide them with the details of the product and its capabilities. More than happy to provide that information.
Okay, thanks, James. Callum, if I can come to you for one of the YouTube questions from Drazen, I think that's how we pronounce it, from Poland, I believe, so thank you for attending. Would you recommend a vapor control layer on the warm side in timber frame construction house and the breathable membrane on the cold side?
Yes, that would be the typical way to do it. depending on the construction, you may be able to negate the vapor control layer as we do in high rise, but in timber frame, you almost always do require the vapor control layer. I would also point out that I'm not entirely familiar with the climate in Poland, and so it may vary slightly.
Yeah, I think Poland gets very warm and also very cold.
It does, yeah.
My understanding is it would be similar. But of course, we do supply projects globally. So, if you take, for example, our projects in the Middle East, we're supplying vapor control layers, which are going in the external face of the building for reverse condensation. So if you are watching this webinar from abroad and joining us, we can actually look at the geographical, climate that where you're based and advise you accordingly. So please send us more information if you have any. Okay, let's have a look here. So we've got quite a few more questions in. I think we've got about 6 more from email and some more on YouTube for those that are staying with us. Sue, I haven't spoken to you for a while. How do you deal with joints when assembling panels on site? So this is actually from Joel, who asked the question about wrap-tight and modular builds. So I'm presuming that's what he means.
Okay, so it's actually a fairly simple process. Obviously, when the panels are erected on site, is basically we would use a strip of the wrap-tight tape, which is the same material as the wrap-tight membrane, and that is used just to continue that airtight seal over the joints of any panels.
Okay, great, thank you very much. James Liam has asked, how do you deal with parapet details?
Similar to as sort of my colleagues have mentioned previously, in regards to the nature of the product, because of the self-adhesive nature, it can bridge over gaps, it can bridge over multiple different components within that parapet. Obviously, you'll be doing a transition from concrete to steel or multiple different, maybe timber system within that parapet. So what we do is, rather than sort of stop at that facade, at the top of the facade, we'd go over the top of the parapet wall, down the other side. Rule of thumb, terminate 150 mil before the deck. But obviously what we'd like to know is obviously what system's actually going on that flat roof, or indeed if it's a gutter system that you're terminating into and then having a pitch roof or mansard roof coming off of the gutter. Just as much detail as we can do in regards to what products are going in there, what insulation's going in there, because obviously there's a multitude of different flat roofing systems out there, whether it's inverted, whether it's a warm roof, whether you've got hot melt, PMMA, or whatever system that you're utilizing on that area. We can accommodate with the termination of the membrane in the correct place, so that you don't need to put extra membranes on top of the wrap-tight in order to protect it from such a product as a hot melt. So yes, we're all about looking at the building holistically. We're all about that envelope. So as long as that continuity is kept up, and you don't expose certain areas, especially high-risk areas such as a parapet, especially the top of the parapet where the cavity may be open, if you encapsulate that with the wrap-tight, then you sort of ensure your airtightness layer is being continuous.
Okay, that's great. Thank you very much, James. Okay, I have one here that's relatively long. Just give me 1 second to reread it before I can just say it out loud. Okay, so from D&H Developments, they're building an EWI timber frame site and wondered if wrap-tight can be used externally with the rock wool dual density EWI on the top. Would we be able to omit the internal membrane? And then they have some details about the makeup of wall. So again, Sue, is that one we would want to go back and get more details about it? Or is that something
probably ask to see the drawings, and we'd be able to then obviously comment specifically on what they're actually proposing to do for this project.
Right, okay, that's absolutely perfect.
There'll certainly be a solution.
Pardon me, Sue, say that again?
There'll certainly be a solution.
Yes, yeah, absolutely. I'm not sure if we do have this, Mark, maybe it's one you'd be aware of. So we've been asked by Gavin, do we have costed examples showing the advantages of wrap-tight on modular systems? So he's obviously looking at the square meter price of the material and has been charged quite significantly over other membranes. So do we have anything cost-wise, or would we be able to talk him through the benefits?
Yeah, we could. If he gets in contact, we can certainly talk him through the benefits and some of the cost savings that you probably don't immediately sort of recognise. I'm not sure that we've got any sort of specific data. I could certainly have a chat with modular manufacturers that are using Raptite at the moment, just to see what benefits they have found in terms of cost savings. But in terms of the construction, that there will be cost savings that will be achieved, because we can take other items out of the build, specifically sort of fixings and tapes and that type of thing, really. So yeah, just please get in contact and we'll discuss it further.
Yeah, it's difficult to look at the sort of square metre price as a like for like, isn't it? So as you said, Mark, to analyse the whole project and the advantages over and above is what we would want to do. Callum, one from Design Coordination and Management. Do you provide a service so architects can send drawings? And do you draw the airtight line and recommend the products needed from our range? So would we be able to analyse these drawings and advise them what to do?
Yes, we would do. So yes, if you can just send them into technical@proctorgroup.com, we'd be able to have a look at them for you.
Okay.
Yep.
And anything else? So just drawings, or is there any other information that you'd need?
Any information that you want us to look at, we can and we will advise on. If you are sending us drawings, we would prefer them in CAD format. It just makes it easier to use them. But we can work with most things that are sent in.
Okay, perfect. Sue, if I can come back to you for another one via email from Zach. Can Fire Shield be used on any substrate?
Okay. In principle, it can actually be used on any substrate. However, the classification of BS1D0, which is what it's classified, would be timber substrate over 10 mil thick, or any A1, A2 substrate, which should be at least 9 millimeters thick and a density of at least, I think it's 510 kilograms per cubic meter. So that's the parameters in which the actual Class B refers to. But obviously, in principle, the Fire Shield will protect or help protect across any substrate, just won't necessarily have that Class B.
Okay. And Sue, how long can, Jason has asked, how long can Raptite membrane be left open before being padded over?
In the UK, we say up to 120 days. We have recently done some testing, however, last year, where we've had membrane exposed for up to a year, was tested every quarter. And what that has shown is that the actual vapor permeability properties after that year has not been affected. Obviously, you still, the 120 days is more for water tightness, etc., but especially just now, if membrane has been left exposed, you can be sort of confident that the actual breathability, vapor permeability of the membrane has not been affected.
Okay, great. Perfect. Mark, Mick has asked, what fixings are recommended for Fire Shield and how do they differ dependent on the substrate type?
Well, Fire Shield is a very robust membrane. It's actually about 730 odd grams, 737, I think, grams per square meter. It's a sort of user-friendly roll, 1.1 meters wide, 20 meters long, but it is quite a heavy material. So we need to make sure, first and foremost, that the fixings are appropriate for the substrate and the application. So you want to make sure that you need to consider the fire performance of those fixings. No point using a plastic fixing for a fire membrane, for example. So there's lots of information that's available on our installation guide. If we look at timber kits, then typically that will be installed like any other membrane, nails or staples. They'll be set at centres no greater than 450 mil. Laps will be 150 mil vertically, 100 mil horizontally. If there's a need for tapes, which will only be required in terms of trying to improve the air tightness, then we've certainly got a tape detail. The membrane doesn't require a tape other than if it's for air tightness. When it comes to other types of substrate, so concrete, sheathing boards and that type of thing, then refer to the data sheet. We work in partnership with fixing companies such as EOT, and they'll be able to clarify the right type of fixing for whatever type of substrate you've got, you're using. And if we're applying it over the top of insulation, then obviously you'll need to think about a fixing with a washer as well, just to fix back through the insulation and then into the substrate behind. So yeah.
Thank you, Mark. James, if I can come back to you just for a couple of application-based ones. You did go over this briefly earlier, but Declan's asked, how would Raptite be used on a high-rise when it comes to movement joints? Can you just explain that in a bit more detail?
Movement joints, that's basically with the expansion joints on the sheathing board. That will be preordained by the structural engineer, depending upon the square meterage, the size of the facade, and where the junctions need to be. Then the Raptite will obviously dress down the facade system, and then where you've got the expansion joints, then it will literally loop out and then join the sheathing board underneath, in order to make sure that the product has that flexibility in it and that it moves with the product, to make sure that, again, that air tightness layer is continuous throughout the facade. Okay,
thank you, James. Probably one for one of the techies, I think. So Sue, we'll go with you, and then I'll ask you the last couple we've had via email, Callum, if that's okay. So Sue, Raptite fitting subject to weather?
Because it's a self-adhesive membrane, as with any tapes, etc., obviously ideally you want the substrate to be dry, dust-free, in order just to get that good adhesion that you would need. So obviously we would not recommend installing it in pouring rain, but yes, dry, dust-free, etc.
Yeah, I mean, we do have testing to show that it does adhere to damp substrates, and obviously,
yeah. I mean, like the advantage of the Raptite is if you have installed it on a damp substrate, because it's vapor permeable, it will allow a degree of drying out. So it's just getting the right balance of, conditions really to install it.
Sure. Okay, that's great. Thank you very much. Callum, last couple of questions. I think you've got away with the least number, so I'll ask you a few more. Okay. Are there any improved installers?
No, we don't have approved installers. For many projects, some of our external team will go to site and offer a toolbox talk, which will talk through the installation of Raptite. And we also offer compliance checks afterwards, so we'll go through and ensure that it's all been installed correctly. It can be installed by any contractors, so ones that are specialising in the SFS or the installation or EPDM. Feedback from contractors has suggested that those installing EPDM are often quickest to pick it up, as they're used to working with an adhered membrane.
Good. And obviously, having built my own house last year, we used Raptite, and I did put quite a big piece of it and installed it myself, just to prove to myself that it was easy as others were telling me, and it really is straightforward and pretty simple. And we've got good installation instructions. I believe we're currently working on installation videos, which should be ready in the coming weeks as well. So we're trying to adapt given the current situation. And last but not least, I think if there's any final questions, please post them now, or Twitter or email, please. Do we have a solution for behind open jointed cladding? Ian has asked, Callum.
Yes, we have our facade shield, which also has a Class B S2D0 rating. And so that can be used behind cladding with joints up to 50mm wide, covering 50% of the facade.
Okay. Okay, and one final one has just popped through, and I think this will be last but not least, so let's switch to Mark. Where services or penetrations through Raptite occur, how should these be detailed to maintain air tightness? Similar to an earlier one we had. But...
Yeah, okay. If you go on our website and go to the Raptite page, there's a detailed installation guide for Raptite and how it's installed, and it has a section on how you detail different penetrations. So you can use the Raptite tape, which Sue said earlier is exactly the same as the membrane, so there's no compatibility issues there. So as standard, that will come 50, 75, 100mm wide. We can cut, as I said earlier, to different widths as well if necessary. So you can use the Raptite to detail around pipe work or steel beams. And then in addition to that, we've got the Wrap-Tight liquid flashing, which comes in it's a gun grade material, comes in a 600ml sausage, for want of a better term. You just basically pump that in around the penetration and use a putty knife to spread that around and make sure that it's evenly spread. And that will ensure you've got the air tightness, etc. Continuous. On the modular side, I've seen the guys using the liquid flashing for detailing where you've got wiring coming through, so different wiring looms and that type of thing coming through the membrane. So again, that's just around there to detail and ensure we've maintained that air tightness. So lots of different solutions and that type of thing. And as we deal with more and more projects as well, then we're finding that there's different types of penetrations that we're coming across. So that again is dropped into the updates as and when we do those on the literature. So yeah, lots of information on the website.
Okay, thank you very much, Mark. Well, thank all of you actually, seeing as we have no more questions to put you under pressure with. I know it's not easy answering when you haven't had questions in advance. So well done, guys. Really appreciate it. And I also want to just say well done to marketing. I really enjoyed that webinar. I thought the pace of it was good, and we took on some comments that we received last week in feedback, and I just thought it was fantastic. So well done. They'll be working already on next week's, frantically trying to prepare, and the week after. So just talking of next week's webinar, please join us again if you can. Go to www.proctorgroup.com/webinar. The topic is protection of buildings on brownfield sites. So it tends to be where there's contaminated land, methane, radon, CO2, VOCs, for example, and we'll be talking through some of the risks of those ground gases and then how to mitigate and which products you can use to do that, along with the services that we offer. You will receive an email after this, which will have a replay, so please circulate it. Fantastic to see so many people watching live today, and actually our webinars have had into the thousands of views in the weeks afterwards. So please circulate it to colleagues and whoever else you may think will find it interesting. Personalised CPD certificates are available below, so have a look, and you can download that and fill in your details, and we will send it directly to you. And I think that's it. Thank you very much for joining us. We love receiving your feedback. We love that people are returning for the webinars, and we really hope to see you all next week. So have a nice weekend. Thank you. Thanks, guys.
Thank you. Bye.